This is Jack Jackson. We're going to talk today about some more inferential statistics. This time we're going to be talking about two sample inferences about proportions. So what we're talking about here is where we have two populations, and we're going to take independent samples from each population. So we use subscripts 1 and 2 to indicate the first population in the first sample, and then the second sample from the second population will have a subscript 2. So for example, n sub 1 is the size of the first sample coming from the first population. N sub 2 is the size of the second sample coming from the second population. X sub 1 is the number of successes in the first population sample from the sample. X sub 2 is the number of successes in the second sample. P sub hat, remember, is our proportion of successes in the sample. So P sub hat sub 1 is the proportion of successes in the first sample. P sub hat 2 sub 2, that is the proportion of successes in the second sample. And what we're interested in is the difference in those two things. So our statistic we're really going to be testing on is P hat 1 minus P hat 2. And it turns out that the mean of that distribution, so the mean of the differences of sample proportions, is actually the same as the difference in the population proportions, P1 and P2. So the mu of P hat 1 minus P hat 2 is the same as P1 minus P2. So that means it's an unbiased estimator, which is of course what we want to have happen. The standard deviation turns out to be P1 Q1 over N1. Now Q1, of course, I mean P1, 1 minus P1 is Q1. So P1 Q1 over N1 minus P2 Q2 over N2, and then take the square root of that, will be the standard deviation there. Now, if the sample sizes are sufficiently large, we can use a normal approximation to get a reasonable approximation for the difference in the sample proportions. And we're going to require that N1 P hat 1, N1 Q hat 1, N2 P hat 2, and N2 Q hat 2 are all greater than 5. So that's going to be sort of our minimal requirement that we can use a normal approximation. Of course, the bigger all four of these numbers are, the better our approximation is going to be. Now, to do this, we also need to estimate the population proportion. And of course, we don't know the population proportion. And so what we're going to do is we're going to use a pooled estimate. And so what we're going to do is we add the two number of successes for the numerator, and we add the two sample sizes for the denominator. And that's going to give us a pooled proportion of successes. So P hat sub P, the pooled estimate, this is going to be our pooled estimate for P, is going to be x1 plus x2 on the top, divided by N1 plus N2, that's in the denominator. So we do that ratio there, and that gives us a P hat sub P. And then our test statistic that we're looking at is P hat sub 1 minus P hat sub 2 divided by the square root of P hat sub P, and then this 1 minus P hat sub P is really like Q hat sub P, and then times 1 over N1 minus 1 over N2. Notice you got a square root over the entire denominator. Now, notice if we use this for a normal approximation, we're approximating twice. So we're pooling the estimate to estimate P, which we don't know if that's accurate or not. And we're also using a normal approximation of what's really a binomial or hypergeometric distribution. But if the size of the samples is sufficiently large, this gives us a reasonable approximation. And so we're going to use this to do the inferences that we're going to do in this class. So all the ones we're going to do in this class, we'll use this approximation, and know that it is approximation. But we're doing this, and it's all built in the calculator as a 2 proportion z-test or a 2 proportion z-interval, whether you're doing the hypothesis test or the confidence interval. And it's based on this setup. So it's pretty straightforward. Let's try an example here. So according to USA Today Online, a survey of 1,000 drivers ages 25 to 34-year-old, that resulted in 270 of them saying that they buckle up when they drive, whereas 330 of the 1,100 drivers, 45 to 64-year-olds, indicated that they buckle up when they drive. So using a 10% significance level, is there enough evidence to suggest that there's a difference in the seatbelt usage of the drivers in these two age groups? Well, this is pretty straightforward to do on the calculator. First of all, we notice that this is a 2 proportion hypothesis testing, because we're testing about proportions, not means or standard deviations. We're testing proportions. Furthermore, the sample sizes are sufficient for us to use a reasonable approximation with a normal curve. So notice that N1 P hat 1 is 270, N1 Q hat 1 is 730, and then X2, which is N2 P hat 2, is 330, and then 770 for the others. So we're looking at the number of successes and the number of failures total in our sample, and each sample in each of those 4 numbers needs to be at least 5. The bigger the better. And in these cases we got reasonably large enough numbers, so we're going to get a reasonable estimate here. So we want to do a 2 proportion z-test, and we just do this in our calculator. Pull up stat, left arrow to test, scroll down until you find 2 proportion z-test. I think it's number 6 or so. Choose that one and enter in the information. X1 is the number of successes in the first sample, so that's 270. N1 is the sample size for the first sample, which is 1,000. X2 is the number of successes in the second group, that's 330, and then the sample size for that second group, which is 1,100. And we're just testing for, it said for a difference, so it's a two-tailed test, so we'll do P1 is not equal to P2. The null hypothesis is always that P1 is actually equal to P2, that the proportions are the same. And so we calculate that test. So entering the information looks like this screen here on the left, and then the screen here in the middle. This is what it looks like whenever it comes out, and notice it gives us a Z statistic. This is a standard normal. So when we went back to this test statistic right here, this is approximately this test statistic here, P hat 1 minus P hat 2 over the square root of all this stuff. This is approximately standard normal. And so there's the Z value that goes with that, negative 1.5198. So in other words, if you compute this here, this is approximately that Z statistic. Okay, and the p-value that we come up with is 0.1285. So about 0.129 for our p-value. The proportions of successes are as 27% or 0.27 for the 25 to 30-year-olds, and 30% or 0.3 for the 45 to 64-year-olds. If you arrow down, you get a pooled estimate of p hat. This is our p hat as our p hat sub p is our pooled estimate, 0.2857. So it's sort of a weighted average of the two. And then here you get your initial, if you go down further, you get the two sample sizes, which of course we had to actually type in. And of course the main thing we're interested in to make our conclusion is this p-value, which is right here. Now unfortunately there's a lot of p's floating around here. We've got our p1 and p2, which are the actual population proportions. We've got our p hat 1 and p hat 2, which are our sample proportions. We got our p hat, or p hat sub p, which is our pooled estimate of the population proportion altogether. And then we've got our p-value, which is our probability value. So we want to look at our p-value, our probability value, to make our conclusion. And of course it is 0.129 compared to our alpha level of 0.1. 10% significance level means alpha is 10% or 0.1. P-value 0.129 is greater than alpha 0.1, and so there is not enough evidence to conclude that there is a significant difference in seatbelt usage of the two age groups. We do not reject the null hypothesis. The null hypothesis says that the two groups are the same, and so we don't have enough evidence to conclude that there's any difference. Okay, let's try another example. Racial profiling is a term used to describe any police action that relies on ethnicity rather than behavior to target suspects engaged in criminal activities. So the question is, does the Los Angeles Police Department invoke racial profiling in stops and searches of the Los Angeles drivers? So this question was addressed in Chance, spring 2006, and some data was collected on stops and searches of LA drivers from January through June of 2005 for two racial groups, the African Americans and whites. And it's given in this table here. You can see that. So we have the number stopped, number searched, and then the number of the ones that got searched, we have the number that actually resulted in finding a criminal activity. So we want to perform a hypothesis test to determine if there's a greater proportion of searches made for African Americans than for whites. And we're going to use an alpha equals 0.05 level. And then we're also going to construct a 95% confidence interval for the difference in proportions. Based on what you've seen already in the last example and other problems you've done, you should be able to go ahead and do this one on your own. So let's have you stop now, do that, and then come back and check your answer here in a minute. Please press pause now. Okay, so when we come back here, here's our table at the top. So to do our hypothesis test, we want to do a two-proportion z-test. So we go to stat, left arrow to test, go down and find the right one, two-proportion z-test, and then enter the data. Now, the number of successes is when they actually do a search here, and the sample size is the number that they stopped. So for whatever reason, they're pulling over some people, and then some of those they're actually searching their cars. And then some of those they actually find something that they can arrest them for in the search. So right now we're only really concerned with these first two columns here, number stopped and number searched, not in which ones find criminal activity. So we're ignoring the last column on the right. So the number searched is our number of successes, the number stopped is our sample size. So X1, sample 1 will be African American, sample 2 is whites. So X1 is 12,016, N1 is 61,688, X2 is 5,312, and N2 is 106,892. And we want to see if the proportion is greater for African Americans, so that is P1 greater than P2. So it's a right-tailed test, the way we have it set up, and so we choose P2 here and calculate. So this first screen here from your TI-84 shows you what that looks like. Now, the results are the screen on the right, and that gives us tells us our alternative hypothesis is that P1 is greater than P2. Our null hypothesis is that the two proportions are the same. So we assume that they're the same unless there's evidence to suggest otherwise, and boy is there evidence here. With a z-value of 94, that gives us a p-value that's 0 to, well, probably less than 10 to the negative 99th, because it would give it to us some approximation if it was closer than that. So this is basically as close to 0 as you can get on this calculator. The proportions are, notice it's about 19.5% for African Americans. They get searched at about that rate, and whites get searched at about 5%. The pool proportion is about 10%, so about 10% of all drivers got searched. And if you arrow down, it would give you this. The only thing left would be the two sample sizes, which we already know. So with the p-value of approximately 0, there is strong evidence to say that the proportion of African American drivers searched is different from the proportion of white drivers searched. The sample proportion of white drivers searched was 5%, and the sample proportion of African American drivers searched was 19.5%. Now, we want to find a confidence interval, a 95% confidence interval for the difference in proportions. We're going to do a 2 proportion z interval, and when it actually comes up, I don't have the screen on here where you enter the information, but it actually turns out to be the same information. It's already coming up because I've already typed it all in. But you type in, the information you type in is really just exactly the same as on this 2 proportion z test, and it just doesn't have the different options for the alternative hypothesis. Hit calculate, and you get this here, and it tells us our 2 sample proportions, our 2 sample sizes, and then the confidence interval. And so a 95% confidence interval for the difference in proportions is between 14.2% and 14.8%. So much higher rate for African Americans. There's definitely some evidence that some racial profiling is going on here in terms of once they have a driver stopped, the proportion of African Americans that gets searched is much higher than the proportion of whites that get searched. Well, what about criminal activity? Is there some reason to believe that one group is much higher in actual criminal activity? Let's take a look at that and see what about comparing the proportion of searches that result in finding criminal activity. So now we're going to think of the searches as being our samples sizes, and then a success is if they actually find evidence of criminal activity. We're going to perform a hypothesis test and a confidence interval to investigate if there's a difference between the two. Go ahead and do that now. Press pause. Well, if you look at what we have here, a 2 proportion z-test. This time the x1 is 5,134, n1 is 12,016. So the number of searches that find criminal activity is our number of successes, and our sample size is just the number of searches. So then for the sample 2, the whites, it's 3,006 for finding criminal activity, 5,312 for the sample size, and we're going to test just that they're different. And sure enough, we get a test that they're different. It's around 10 to the negative 63rd, about 9.7 times 10 to the negative 64th. And for the p-value, so basically, basically 0 for the p-value. So we have extremely strong evidence, again, to show that the proportion of searches resulting in criminal behavior is different for the 2 groups. Okay? Actually, the sample proportion of criminal behavior in whites was 56.6, where it is actually 42.7 for African Americans. So again, this is some evidence to support the fact that the racial profiling, not only is it occurring, it's not even being useful in helping them catch criminals, because the proportion that they're catching on the whites is significantly higher. So 95% confidence interval for the difference, we run a 2 proportion Z interval, and it's negative here because I'm doing African American minus white. So the proportion of African Americans that are actually being found with criminal activity, if they're searched, is somewhere between the proportion is somewhere between 15.46% and 12.2% to 6% less than it is for whites, and we're 95% confident that that happens. So this is another type of test that's very commonly used and pretty straightforward if we use the built-in test, the 2 proportion Z test, the 2 proportion Z interval in our calculator. Now, of course, this is approximation, and it really gets better and better approximation as the sizes of the number of successes and failures in the sample, in both samples, increases. So we need a big sample size for this to work pretty well. If we get really small sample sizes, these are going to be considerably off, and we need to use some other technique. But if we got large sample sizes like we're dealing with here, this is going to be quite good.